Humidification in chemical engineering. It will be explained to you today by Sadia, Tanweer, Amreen, and Karishma.
But first, let's get to know a bit about chemical engineering before we jump right into humidification in chemical engineering. So, what do you think chemical engineering is? If you want to know more about chemical engineering, let's go to the next section of this video together. So, chemical engineering is a type of engineering that deals with studying the operation and design of chemical plants. It also deals with chemical production and manufacturing products through chemical processes. Now that we have learned a bit about chemical engineering, now let's see how a chemical plant looks like. Here are some images of how a chemical plant looks like. These are 3 different kinds of chemical plant. Now, let's look at some of the products manufactured in chemical industries. Simple products like soybean oil, plastic bag, and salt are produced in chemical industries. Now, let's see how humidification is used in chemical industry and also is very important to chemical engineering. Humidification is a chemical process widely used in the chemical industry and chemical engineering studies. Now, let's check out what's humidification. So, in this section, you will be learning a simple definition of humidification. Humidification is the process of increasing the moisture content of the air. In this process, moisture is added to the air without changing its dry bulb temperature.
Have you ever wondered why does it feel hotter when the humidity is high? Well, this can be explained by a simple autonomic nervous system in our body. When the surrounding temperature is very high, we tend to sweat more. This is done to cool off our body. Sweating evaporates a big portion of heat from our body. But what happens when the relative humidity in the air is very high? The high humidity results in more amount of moisture in the air, which eventually slows down the sweat evaporation from our body, allowing less room in the air for additional moisture. Now, to understand humidity better, let's imagine a weather forecast. On a 30-degree day with a humidity of 70%, it feels like it's 39 degrees Celsius. This shows how humidity affects the weather on a daily basis. Humidification allows the conditioning of gases or cooling of liquids that are applicable to any gas or liquid system. That is why humidification process is very important within chemical industries. This process has high profitability and low operating cost. Most cooling towers work based on the principle of evaporative cooling. Evaporative cooling is the process where warm water from an industrial process is pumped up to the top of the cooling tower where the water distribution system is. The water then gets distributed by cooling tower nozzles to the wet deck. At the same time, air is being drawn through the air inlet louvers, forcing water to evaporate. Evaporation causes the heat to be removed from the makeup water. The hot air naturally rises out of the tire. Now, when we look into humidification in chemical engineering, we refer to a few terms such as dry bulb temperature, wet bulb temperature, dew point temperature, relative humidity, and enthalpy. But you must be wondering, what are these terms? Well, a dry bulb temperature is basically the ambient air temperature. It is called dry bulb because the air temperature is indicated by a thermometer not affected by the moisture of the air. On the other hand, a wet bulb temperature essentially measures how much water vapor the atmosphere can hold at current weather conditions. The dew point temperature is the temperature the air needs to be cooled to in order to achieve a relative humidity of 100%. Whereas the relative humidity tells us how much water vapor is in the air compared to how much it could hold at that temperature. And finally, what is enthalpy? When a substance changes at constant pressure, enthalpy tells how much heat and work was added or removed from the substance.
Now, let's learn about the cooling tower. What is a cooling tower? A cooling tower, which is also known as a humidification tower, is designed to remove heat from cooling water of a building or chemical plant. Simultaneous heat and mass transfer take place from the hot water to the air rising upwards. Heat exchange that occurs in a cooling tower is called the humidification process. This is the cooling tower found at UTM. There are two types of cooling tower: natural draft cooling towers and induced or mechanical draft cooling towers. Natural draft cooling towers are made from concrete in a hyperbolic shape to introduce airflow due to the difference in density and temperature through the stack from underneath. It is used by utility power stations. Some of the benefits include no fans required, so more power saving, low maintenance, no corrosion, and no air recirculation as stack outlet is located high up. Drawbacks include can only be installed outdoors and it requires large space. For induced draft cooling tower, hot water enters from the top where huge fans on the outside are used to induce the air from bottom up to the top. It is more widely used than natural draft cooling towers. Benefits of such a cooling tower include low absorb capacity, maximize the contact time between water and air which will increase the heat transfer between them, can be installed in a smaller space, and no air recirculation. Drawbacks include air distribution problems if there is uneven flow, leakages, and require weatherproofing against moisture and corrosion. So, for the process of cooling tower starts with spray of hot water from the condenser's flue, which is routed from the top and is allowed to flow downwards over a packing against a countercurrent flow of air entering at the bottom. Heat is transferred when the air travels through the water and part of the water evaporates. This heat and evaporated water generate a thin cloud-like mist that flows out of the top of the tower. At the bottom of the tower, the cooled water is collected and pumped back into the plant or building for reuse.
Now, let's talk about the applications of humidification in a cooling tower. Cooling towers are used in heating, ventilation, and air conditioning HVAC systems found in office buildings, schools, and hospitals. Cooling towers are utilized in power plants, petroleum refineries, petrochemical plants, natural gas processing plant, and food processing plant. Cooling towers provide cost-effective and energy-efficient operation of removal of the heat absorbed in circulating cooling water systems. Evaporative gas turbine pilot plant is one of the industrial plants that uses the application of humidification. In the EVGT cycle, which is from the evaporative gas turbine power plant, heated water is brought into countercurrent contact with the compressed air for water evaporation in the humidification tower. The humidification tower is equipped with structured packing 900 mm high. This is done to accomplish simultaneous good mass and heat transfer in the column. Thus, the gas mass flow rate will increase, hence higher specific power output and efficiency due to the added vapor. Various enhancements were done on the cooling tower so that it works efficiently. Several spray nozzles were installed to ensure that there was an even water distribution. The heat of vaporization was taken from the flue gases and, if possible, from an intercooler and aftercooler prior to the humidification tower. The exiting humidified air from the column is preheated in the recuperator before the combustion chamber. And lastly, recovering the heat from the flue gases is thermodynamically sound than producing steam in a bottoming cycle. While an aftercooler is a heat exchanger that operates by cooling the air emerging from a compression unit, an intercooler is a device attached to an air compressor that cools the air before engine intake.
So that's all from us. Hope you learned something new today, and thank you for watching.